You're welcome to my Create Math YouTube channel where I'm devoted in building students zero tolerance for the fear of mathematics. In this video, I'll be walking you through the solution to the M81 to 2 continuous assessment test questions for 2018-2019 section. You'll learn how to solve standard calculus exam or test question without losing any points. So for all year 1 students in University of Lagos offering this course, this video is made just for you. You see, you don't just learn by watching, you need to get your pen and paper and walk along with me. Now before I go ahead, help us to share this video to your class group chats. There are a lot of students out there that this is exactly what they just need for them to pass this course. Also, don't forget to subscribe to this channel if you haven't done that. So, without further ado, let's head over to our video for today. Question 1. It said, given that 4y squared multiplied by x minus 5x squared multiplied by y cubed plus 4y is equal to 0, find the y dx at 1, 1. So here we are given that 4y squared multiplied by x minus 5x squared multiplied by y cubed plus 4y is equal to 0. So we want to find the y dx at point 1, 1. Now for us to do that, we need to differentiate each term here with respect to x. Okay, for us to find out the y dx, so we need to differentiate each term here with respect to x. And if we do that, so what are we going to have? So that means we are going to have this to be d dx of 4y squared multiplied by x minus d dx of 5x squared multiplied by y cubed, then plus d dx of 4y to be equal to d dx of 0. Alright, so we are trying to differentiate each term here with respect to x. Now if we do that, here, since you know that your y is still a function of x, so that means we can apply our product rule here. Now you need to be careful when you're applying your product rule. If we apply our product rule, that is if we call the first two terms here our u and the last term here our v. Alright, so that means you can recall your product rule that if you have your y to be equal to uv, and that means the derivative of your y with respect to x will be what? U dv dx minus plus v du dx. Alright, so if you do that, so that means we are going to have this to be u, that is 4y squared dv dx, that's our v here is x, so we replace it with x, then plus x, then d dx of what? 4y squared, then minus here and have this to be minus of what? 5x squared, then here we have d dx of y cubed, then plus, right, because you are applying product rule here also. So I'm actually applying product rule here, so that means here I'm going to have this to be y cubed, then d dx of 5y squared or 5x squared, should be 5x squared. Alright, so this should be 5x squared, then plus 4 dy dx to be equals to 0. Okay, so now we have that result. So now if you differentiate this, that means we are going to have this to be 4. If you differentiate x with respect to x, that means we are going to have this to be 1, then multiply by y squared, 4y squared, that means we have this to be what? 4y squared, then plus x multiplied by, now if you differentiate, now this is, I'm having 4y squared, alright, now, and I want to differentiate this y squared with respect to x. I can just try to manipulate this to be what? So I'm going to have this to be, I can write this as d dy of 4y squared, then multiply by dy dx. I'm just using my idea of chain rule to write this. I want to bypass, I want to differentiate y squared. Okay, I want to make sure I differentiate y squared. So I can achieve that by differentiating it with respect to y first, then now multiply by dy dx. Alright, so that's kind of clear. Then minus, again here, this is, I can write this as what? 5x squared, then multiply by d dx of, or d dy of y cubed. I need to differentiate it with respect to y first, then now multiply by dy dx. Alright, so then that's just from your idea of implicit differentiation. Then plus here this is already a function of x, so I can differentiate this. So this is y cube multiplied by, if we differentiate this now, so that means we are going to have this to be 10x, then plus 4 dy dx to be equals to 0. Now if we simplify it further, so that means we are going to have this to be 4y squared, then plus, now if you differentiate this, that means we are going to have this to be multiplied by 8y, then dy dx, minus, here we are going to have this to be, if you differentiate this with respect to y, that means we are going to have this to be 3y squared. So 3y squared multiplied by 5x squared, that means this will give us 15x squared y squared dy dx, then plus, now here again, if you multiply this out, so that means we need to have this to be, then there's minus out here, so that means this will just be what, this will be minus, this will be minus 10x y cube, then plus 4 dy dx. Now since I'm interested in my dy dx, so I can just try to collect all the terms that contains dy dx. All right, so that means my differential coefficient, so that means I'm going to have this to be 8xy minus 15x squared y squared, then plus 4, then that's multiplied by my dy dx. All right, so to be equals to, now if I bring all the terms that doesn't contain dy dx to the right hand side of the equation, so that means I'm going to have this to be what, 10xy cube, then bringing this to the other side, that means I'm going to have this to be what, minus 4y squared. All right, so that means I can write my dy dx to be equals to 10xy cube minus 4y squared, all divided by 8xy minus 15x squared y squared plus 4. All right, so don't forget that the question says I should find dy dx at 0.1, 1. So that means my dy dx at x equals to 1 and y equals to 1, okay, would be what? So if I replace my x with 1 and my y with 1, so what am I going to have? So that means I'm going to have this to be what, 10 multiplied by 1 cube minus 4 multiplied by 1 square, all divided by what, 8 multiplied by 1 multiplied by 1 minus 15 multiplied by 1 square, then plus 4. Then that means you are going to have this to be 1 minus 4 would give us 10 minus 4 rather would give us 6. Then here we have 8 minus 15 plus 4. 8 plus 4 will give us 12. Then 12 minus 15 would give us minus 3. All right, so here we have 12 minus 15. This will give us minus 3. So 3 divided by minus 6 divided by minus 3 will give us what, minus 2. All right, so the correct option, the correct answer to this question is what, minus 2. So make sure that you write your answer clearly. All right, so let's move on to the next question. Before we move on to the next question, we need to erase all the solution. All right, in this question 2, they said evaluate the integral from 0 to m of 12x squared dx to be equals to 500 to obtain the value of m. Now from your elementary class in calculus, you remember that if you have the integral of, let's say, some function f of x, taking the limit a, lower limit to be a and the upper limit to be b dx. All right, so from your idea of the fundamental theorem of calculus, okay, so this is going to give us what? It's going to give us f of b minus f of a, okay, where where your f of x is the antiderivative of your function f of x, this small f of x here. Okay, so now what I'm saying in essence is that here we are given the lower limit to be 0 and the upper limit to be m, and this to be 12x squared dx to be equals to 500. All right, so meaning that if we try to integrate this function, we are going to have this to be 12x cubed divided by 3, taking the lower limit m, taking the lower limit to be 0 and the upper limit to be m to be equals to 500. Now here we can have this to be 4x cubed 0m to be equals to what, 500. I just try to simplify this. Now here, if we substitute the value of m here, so that means we are going to have this to be what, 4m cubed. Okay, now if you substitute the lower limit, this will give you 0 to be equals to 500. So that means we have 4m raised to power 3 to be equals to 500. So if you divide both sides by 4, that means my m cube is going to be 500 divided by 4 would give us, so here we have 500 divided by 4 will give us 125. And what's the cube root of 125? The cube root of 125 is just 5. It's just 5. So the correct option to this, or the correct answer to this question, is what, is 5. All right, so let's move on to the next question. In this question, they said find the derivative. So here we asked to find the derivative of e raised to the power of ln 3x squared all divided by ln x. Okay, so we want to find the derivative with respect to x. Now you observe something, that here we want to find the dx of e raised to the power of ln 3x squared all divided by ln x. Okay, so now you can actually apply your chain rule to this, but before you apply your chain rule, before you solve any problem, you try to observe that problem to see if you can actually reduce the complexity of that problem by by a little bit of simplification. Now here I observe that if I have a number a, the number a can be written as e raised to the power of ln of a. So that means if I have e raised to the power ln anything, that means it's just that number. Okay, so that means here you can agree with me that I can rewrite this as ddx of here 3x squared over ln x, and I can now conveniently apply my quotient rule. And if I apply my quotient rule, you all recall the quotient rule that if you have y to be equals to u over v, all right, so what's my dy dx? My dy dx is just what, v u prime minus uv prime all divided by v squared. Okay, when I say u prime, I'm referring to derivative of u with respect to x, and if I say v prime, I'm referring to derivative of v with respect to x. Oh, I think you're all familiar with that. So let's just move on. Now here if I do that, so I'm trying to call my denominator my v and my numerator as my u. You are all familiar with that. So that means we are going to have this to be the denominator, which is ln x, multiplied by the derivative of the numerator, that's 3x squared, minus 3x squared multiplied by the derivative of ln x with respect to x all divided by ln x squared. Okay, so this means this is ln x multiplied by ln x. All right, so you can equally put your brackets, but this is still okay. Now if I do that, so that means I'm going to have this to be ln x, and if I differentiate 3x squared with respect to x, so that means I'm going to have this to be 6x minus 3x squared, and again multiply this by, if you take the derivative of differentiate ln x, that means I'm going to have this to be 1 over x all divided by what, ln x all square, and this will give me what, this will give me 6x ln x minus 3x, because here I have x squared and here multiplied by 1 over x, so that means this is going to reduce to what, 3x all divided by ln x square. All right, so from your elementary you will also recall that if I have a plus b over c, this can be written as a over c plus b over c. All right, so that means you agree with me that this is what ln x multiplied by 6x all divided by ln x square minus 3x all divided by ln x all square. Okay, so that means you cancel one of these, and that means I'm going to have this to be 6x all divided by ln x, then minus 3x all divided by ln x all square. Okay, so this is our correct answer to this question. Now I would just advise you guys that anytime you are solving your problem, make sure that you observe very well, because there's a reason why they are setting this question. So it's not just about, you know, picking your pen and solving. You need to observe. That's why the time is 1 hour. Okay, there are some things that can easily cancel out if you calm down to look at the question very well. That's just one thing about calculus problem. You just need to observe before you solve your problem. So that one is just by the way. So the correct answer to this question is 6x all divided by ln x minus 3x all divided by ln x all square. Alright, so let's proceed to our next question. In this question, that's question 4, we have to find the integral of the square root of tan x all divided by sine x multiplied by cos x. So we want to find the integral of the square root of tan x all divided by sine x multiplied by cos x dx. Alright, now for us to solve this problem, we can just use this transformation. That is, we can say let our t be equals to tan x. Okay, we can say let our t be equals to tan x. Now suppose tan x is not here, I can just use let our t be equals to tan x over 2. That is if tan x is not in our integrand. Alright, so here, but we have tan x here, so I can just use my t to be equals to tan x, which will still make my integral much more easier to solve. Now if my t is equals to tan x, what does that imply? That implies that what my x is simply arctan of t. Alright, so that means if I differentiate my x with respect to t, I'm going to have this to be 1 over 1 plus t square multiplied by dt. Okay, if I just multiply both sides by dt, alright, I will have that result. Now also, if I try to draw a triangle for this, since I'm using a trigonometric substitution, so that means I need to draw my triangle. Now here I have tan x, so let's say this is my angle x, and since you know that your tan theta from the idea of SOHCAHTOA, tan is just opposite over adjacent. So here I have my opposite to be t and I have my adjacent to be 1. Alright, so this is just in t ratio 1, so I have this to be t ratio 1. So what will be my hypotenuse? My hypotenuse will just simply be what, from your idea of Pythagoras theorem, so this will just give me the square root of t square plus 1. Alright, so here we have that to be t square plus 1. Okay, so that means we are good to go. So that means the integral of tan x all divided by sine x cos x dx is simply what the integral of, that's square root of t. Okay, square root of t all divided by, now so what will be sine x? From the idea of SOHCAHTOA, sine will just be opposite over hypotenuse. So what's my opposite? My opposite is just t over hypotenuse, which is square root of t square plus 1 multiplied by cos t. So what's my cos t? My cos t is just adjacent over hypotenuse, which is 1 over the square root of t square plus 1. Okay, then multiply by my dx. So my dx here is now 1 over 1 plus t square dt. Now anytime you are transforming, make sure that you always get the value for your dx. don't just go and integrate t with respect to x. A function that is a function of t, and now integrate it with respect to x, you may not get your answer. So make sure that you have this with respect to t. The variable here must still be the same thing as the variable here. Alright, so let's move on now. Here, that means this will simplify to what? Square root of t, all divided by, now here I have square root of a multiplied by square root of a. That means this will give me t over 1 plus t squared multiplied by 1 over 1 plus t squared dt. So this will give me the square root of the integral of the square root of t over t, because this will cancel out this, then I will have this to be the t. And now this can be written as the integral of, now I have this to be t raised to the power of minus 1 over 2 dt, which is what? T raised to the power 1 over 2 over 1 over 2 plus c, or you write it as 2 root t plus c. Okay, but we make a substitution here that our t is actually tan x. So that means I'm going to have this to be 2 multiplied by square root of tan x plus what? Plus c. So the value of this integral is what? 2 multiplied by the square root of tan x plus your arbitrary constant c, since it's an indefinite integral. So that means I have my result here to be 2 square root of tan x plus c. Alright, now you have to take note here that since it's an indefinite integral, I need to add my arbitrary constant. Okay, the lecturer can decide to remove some certain mark here, since you are since you don't add an arbitrary constant. So our answer is 2 square root of tan x plus c, and don't forget to add your arbitrary constant. So let's move on to the next question. In this question, they said, that's question 5, what is the integrand of the integral? So here we are given the integral of e raised to the power negative x sine e raised to the power negative x dx. So they are asking us that what is the integrand? Okay, so the integrand of the integral. Now if you are given, let's say you have an indefinite integral of this function f of x dx, this function, the f of x here, your f of x here is called the integrand. Alright, so that means, so what is the integrand of our integral? It's just the function here, primitive function, that is what? E raised to the power negative x sine e raised to the power negative x, and you are done. So this is just your answer. Alright, so let's move on to the next question. So in this question, that's question 6, said find two positive numbers whose sum is 100 and product is minimum. Okay, actually the question is wrong, it's supposed to be maximum. Alright, so now it said find two positive numbers. So let's say the numbers, let's say the two numbers are positive. They said given that the two numbers are positive, so let's say the first and second number y are positive, that is they are greater than 0, whose sum is 100. Now here we are given that their sum is 100. Okay, so let's say this is our equation 1, and also they said and product is maximum. Okay, now meaning that let's say the product of those two numbers, let's call them p, which is xy. Alright, so let's say this is our equation 2. Now from equation 1, if I make my y the subject of formula, that means from 1 I'm going to have y to be equals to 100 minus x. So let's call this one equation 3. So if I substitute equation 3 into equation 2, so that means I'm going to have my p to be equals to x open bracket. So what's my y? So I can replace my y to be 100 minus x, which will give me what? 100x minus x squared. And if I take the derivative of p, with respect to x, that means I'm going to have this to be 100 minus 2x squared. And again, if I take the second derivative of p with respect to x, alright, I'm going to have this to be, this should be ordinary minus 2x, not minus 2x squared, because I'm differentiating x squared with respect to x. So note that correction. And if I take the second derivative of p with respect to x, I'm going to have this to be minus 2. And you know that if the second derivative is what is negative, that means I'm going to have a maximum. Alright, I'm going to have maximum. And if the second derivative is positive, that means I'm going to have a minimum. Okay, so this occurs when your second derivative is what is negative, and this occurs when your second derivative is positive. Is what is positive. So if the second derivative is positive, that means we are going to have a minimum. If it's negative, that means we are going to have a maximum. What this tells you is that the slope here is what? The slope here is kind of decreasing. Okay, it was increasing before, then it started decreasing. So that means that is what minimum. Maximum. Okay, so that's why we have this to be this. So this is maximum. Alright, so we have our second derivative to be negative, so that means this is a maximization problem. Okay, now after that we can now set our dp dx to be 0. So if we set our dp dx to be 0, so set dp dx to be 0, so that means we are going to have this to be 100 minus 2x to be equal to 0. So that implies that our 2x is equals to 100, and that means our x is what? Our x is 50. Alright, so we have our x to be 50. Now we can actually substitute x to be 50 in equation 3. So that means we are going to have our y to be equals to 100 minus 50, which is what? 50. So that means that our x comma y is what? 50 comma 50. So this is the maximum product. So the maximum product is just 2500. So that will be our maximum product. So but here they are asking us to find the two positive numbers. So the two positive numbers are just 50 and 50. So this is just, you can just write it as 50 comma 50, or you can write it as x comma y to be equals to 50 comma 50. Alright, you can write them in pair form, just 50 comma 50, just to let them know that our x is 50 and y is also 50. Okay, so let's move on to the next question. In this question, we are asked to find the derivative of y equals to the square root of sine x. This is pretty much simple. We can just use our chain rule to do that. So we have y to be equals to square root of sine x. And now, if we let our u be equals to sine x, so that means our y is going to be what? Square root of u. Alright, so if we replace our u with sine x, that means our y is going to be what? Square root of u. And if we differentiate our u with respect to x, so that means we are going to have this to be what? Cos x. Not only that, if we differentiate y with respect to u, that means we are going to have this to be 1 over 2 square root of u, which is the same thing as 1 over 2 square root of sine x. So by chain rule, our dy dx is what? Dy du times what? Du dx. So what's our dy du? Our dy du is what? 1 over 2 square root of sine x, and our du dx is just what? Cos x. So that means our answer is going to be what? Cos x over 2 square root of sine x. So you can leave your answer this way. So our correct answer here is what? Cos x all divided by square root of 2 multiplied by square root of sine x. Okay, so let's rub the board up. So the next question, they said we have to find evaluate the integral of what? X minus 5. That's question 8, all divided by x squared minus 3x plus 2 dx. Okay, now you observe that x squared minus 3x plus 2 can be written as, so this integral can be written as x minus 5 over, I can actually factorize this denominator, so I can write this as x minus 1 multiplied by x minus 2. Alright, this is just from your basic quadratic classes. So dx. Now, since I'm able to factorize the denominator into two linear terms, that means I can resolve it into partial fractions. So let's try to resolve that into partial fractions. So that means I have x minus 5 over x minus 1, then x minus 2 to be equals to a over x minus 1, then plus b over x minus 2. So that means I'm going to have x minus 5 to be equals to a into x minus 2 plus b into x minus 1. Now, when I set my x to be 2, that means I'm going to find the value of my b. So when x is 2, that means I'm going to have this to be minus 3 to be equals to b. Okay, and when x is 1, so I want to look for my a, that means I'm going to have minus 4 to be equals to minus a. So that means my a is what? My a is 4 and my b is what? Minus 3. So what I'm saying in essence is that the integral of x minus 5 over x squared minus 3x plus 2 dx can be written as the integral of a, which is 4 over x minus 1 dx, minus b, which is what? The integral of 3 over x minus 2 dx. Alright, so now you recall that anytime you have the integral of, the derivative of what you have at the denominator over what you have at the denominator, this is just ln of what you have at the denominator plus c. Okay, so here we can have this as 4 ln x minus 1. Okay, since you know that if I differentiate x minus 1 with respect to x, I will still have 1. So that means I'm going to have this to be, I'm going to have this to be 4 ln x minus 1, then minus 3 ln x minus 2 plus c. Okay, don't forget that this is an indefinite integral, so I need to add my arbitrary constant to it. So that means the correct answer to this question is what? 4 ln absolute value of x minus 1 minus 3 ln x minus 2 absolute value of x minus 2 plus c. Now why we had absolute value is because I know that the logarithm function on a real value function takes a positive argument. Alright, for me to get my answer on a real line, the argument here must be positive. My x has to be positive. So to remove all cases, or to remove all those exceptions, I just take the absolute value. Since I know that my absolute value is also a positive real value function, it will always return a positive answer, no matter the value of r, no matter my value of r, okay, or no matter the value of the point I pick in my real value or in my real numbers, I will still get a positive answer. So that's why I just take the absolute value. I think that's pretty much clear enough. So let's move to the next question. Alright, so in this question 9, we are asked to evaluate the integral from 0 to 1 of the square root of 3x minus 1 dx. Okay, now let's do it together. If you have the integral of 0 to 1 of the square root of 3x minus 1 dx, so we want to find the definite integral of this. Alright, so to make all things go easier for us, we can just say let our u be equals to 3x minus 1. Alright, so and if I differentiate u here, I'm going to have this to be 3 dx, okay? Because if I differentiate 3x, I'm just going to have this to be 3 dx, okay? Another thing here is that I need to transform, since I'm using this transformation u to be equals to 3x minus 1, I also need to transform my limit. So I normally draw a box, okay? Then I'm going from where? I'm going from x to what? To u. So that means when x is 0, that means my u is minus 1. And when x is 1, my u is what? My u is 2. So that means that the integral from 0 to 1 of the square root of 3x minus 1 dx is simply the integral from minus 1 to 2 of the square root of u multiplied by, now, so what's my dx here? My dx is just du over 3. So that means I have this to be what? Du over 3. So that means I have this to be 1 over 3 integral from 0, no, not from 0 again, that's from minus 1 to 2 of the square root of u du. And here I'm going to have this to be 1 over 3. So if I integrate this, I'm going to have this to be 2 over 3 multiplied by u raised to the power of 3 over 2, because this is just u raised to the power 1 over 2. Then if I add 1 to it, so that means I'm going to have 3 over 2. So this is pretty much clear. So that means I have this minus 1 to 2. And here, this is just 2 over 9. Then u raised to the power 3 over 2. Then lower limit and the upper limit. So I need to substitute those two limits inside the argument here. So I have 2 over 9. Then here, if I substitute 2, that means I have this to be 2 raised to the power of 3 over 2. So 2 raised to the power 3 over 2 will give us 2 raised to the power of 3 over 2 would give us 2 root 2. Okay, so will give us 2 root 2. So here, this will give us 2 root 2. Okay, now, not only that, if I substitute the value of minus 1, so here I have minus 1 raised to power 3 over 2. So minus 1 raised to power 3 over 2 is what? So here we have square root of minus 1 everything raised to power 3, which will give us minus, this will give us I raised to power 3, which will give us minus I. Okay, so here we have lowered limits to be minus I. Then here we are going to have this to be minus, because we are taking minus lower limit, so we have this to be minus, then minus I. Okay, so that means we have this to be what? 2 over 9 open bracket 2 square root of 2, then plus I, so which is our final answer. So the correct answer to this question is 2 over 9 open bracket 2 root 2 plus I. Alright, so let's move on to the next question. So question 10, we are asked to find the integral of sec x dx. This is actually a standard integral. Now here we have sec x. I can actually multiply the numerator by sec x plus tan x. Sec x plus tan x. Then multiply the denominator also by sec x plus tan x. I haven't changed anything. I just multiplied the numerator by sec x plus tan x, and also multiply the numerator also by sec x plus tan x. Then I have this to be all dx. Now, what do you observe? If I differentiate sec x plus tan x, I'm just going to have what I have at the numerator here. So I can write this as integral of d of sec x plus tan x, then divided by sec x plus tan x. What will this give us? This will just give us what? The ln of sec x plus tan x plus what? Plus c, because of the indefinite integral. Okay, so our correct answer here is what? Ln of sec x plus tan x then plus c. Alright, so in this question they said find the non-positive point on the curve y equals to 12x minus x cubed at which the slope is 0. So we want to find the point at which the slope is 0. Alright, so first thing is that we find the derivative of the function. So what's the derivative of the function? Derivative of the function is given as, now here we are given y to be equals to 12x minus x cubed. So that means my dy dx would be what? That's 12 minus 3x squared. Okay, so we need to set our derivative to be what? Said question says find the point on the curve at which the slope is 0. So for the slope to be 0, so that means that point has to be critical. It has to be a critical point. So setting our dy dx to be 0, that means we are going to have this to be 12 minus 3x squared to be equals to what? 0. That means we have this to be 4 minus x squared to be 0. That means I'm going to have this to be 2 minus x multiplied by 2 minus x from your idea of difference of 2 squared to be 0, and you can find x to be what? Minus 2 or what? 2. Okay, they're asking us to find the point. Okay, the point. So that means we need to find our corresponding y-axis. Now, where the slope, find a non-positive point. Non-positive. When it's a non-positive, that means the negative point. So we need to pick this negative 2. So when x is negative 2, okay, so what's my y? So my y is just what? 12 multiplied by minus 2, then minus 2 raised to power 3. This will give me minus 24, then my plus 8. Okay, so minus 24 plus 8 will give me minus 16. So the non-positive point here is just minus 2 comma minus 16. So minus 2 comma minus 16. So the non-positive point is minus 2 comma minus 16, and you can see that displayed in the graph at the left hand side of the screen. Alright, so let's move on to the next question. So in this question they said for what values of mu is the function f of x equals to it's sine 5x over 2x when x is not 0, and mu when x is what? 0, continuous at x equals 2. Now before I solve this problem, I want to just quickly give a general overview of what we mean by continuity at a point. Now when you talk about continuity at a point, now let's say we have this graph here, a small graph here. Alright, so I have something like this. Now let's say this is my point C. Okay, and I have another graph here. Okay, so I have something like this at point C here. Alright, so this is like point C. Now if I should ask you which of the 2 points here is which of the 2 curves here is continuous. When you talk about continuity, you're trying to draw a curve conveniently without lifting your pen. Now I can actually draw, let's say this is my fig 1 and let's say this is my fig 2. Alright, now if you look at the two graphs clearly, you'll see that I can actually draw I'm referring to the first figure here. I can actually draw it without lifting my pen at point C. But when you look at the second figure, when you want to draw your curve, there's a break here. It's actually, a break here. So this is not continuous. This is not continuous at what? At x equals c. Alright, why this is what? Continuous at what? At x equals c. Okay, now let's try to come up with a formal definition of continuity, or when do you say a function is continuous at a point? To me, a function is continuous at a point if, okay, let me try to draw a graph. Let me just try to draw a graph to illustrate what I'm saying. Now let's say we have something like this. Let's say my graph is like this. Okay, and let's say this is my point C. All right, now this function is continuous if three conditions are satisfied. All right, the first condition is that if my f of c is what? If my f of c is defined. If f of c is defined. So let me try to rub this off. All right, it's clearly is defined. Or another one, if your f of c exists. All right, if the value of this function here at point C, if it exists on the y coordinate, so that means, all right, so that's one of the conditions. The second condition is that if the limit at which x tends to c from the right is still the same thing as the limit at which your point x tends to c from the left, all right, if they are equal, all right, and your f of c is defined, and so if they are equal, definitely your f of the limit at which your x tends to c of your f of x must be equal to your f of c. All right, so if the left limit is still the same as your right limit, that means your that means this is still the same thing as the limit at which x tends to c of f of x. Okay, if the left limit is still the same thing as your right limit, that means the limit at this point, that means they are equal. All right, so that means it's still the same thing as when x is tending to c. All right, so that means that will give us our f of c. So that means this function is continuous at what? At c. And you can see it that the left limit at which the value as x approaches c from the left, so this is approaching it from the left, x is approaching c from the left. Okay, y here, that means x is approaching c from the what? From the right. Okay, so x is tending to c from the right, x is tending to c from the left, and you can see that they are both approaching this value of f of c. So that means this function is continuous at what? Is continuous at point c. All right, so now let me just ask you guys a question. Now let's say I give you guys this graph. Now I want you to tell me if this function is continuous at, this is my f of c, this is my f of c, and this is my c. So I want you guys to tell me, is this function continuous? Is my f continuous? Is f continuous? All right, so I want you guys to tell me, is my function continuous? Okay, you can just drop your answer in the comment section box below. All right, so I want you to tell me if this function is continuous. Why is it continuous? If it is continuous, why is it continuous? If it's not continuous, why is it not continuous? Okay, I want you guys just to think about it. So back to our question. What values of x of mu is the function continuous at 0, at x equals to 0? Now, from my explanation I gave earlier, you can say that this function is continuous at x equals to 0 if the left limit, all right, if the limit at which x tends to 0 from the negative of f of x is what is still the same as limit at which x tends to 0 from the right of your f of x, and it's giving me my f of 0. That means that this function is continuous at 0. Now, what is my left limit? My left limit, that is the limit at which x tends to 0 from the negative side. Okay, so if you look at your condition, they said x is not 0. That is the condition where x is not 0. So the condition where x is not 0 would be the condition where x is approaching it from the left. Okay, so if x is not 0, that means either x is greater than 0 or x is less than 0. Okay, so alright, so meaning that if x is not 0, that means either x is positive or x is negative. Alright, so if x is negative, that means that what it will still give me what? It will still give me this value. So if it is approaching it from the left, so that means I'm going to have this to be the limit at which x tends to 0. So which function will I use? I will just use this function, this first function here, which is what? Sine 5x over what? Over 2x. Alright, I hope that is clear enough. Now, I can actually manipulate this. Alright, so I can have this to be what? To be the limit at which x tends to 0 of what? Now, here, I'm going to have this to be 5x sine 5x all divided by, now if I multiply the numerator here by 5 and I also multiply the denominator here also by 5, so that means I'm going to have this to be 5 over 2 multiplied by 5x. Alright, so I just want to have something like this. I want to have the limit at which x tends to 0 of sine x over x. So the argument I have here must also be the argument I have here. Alright, and you know that this limit at which x sine x over x as x tends to 0 would give us what? Would give us 1. So that means this is what? 5 over 2. And the limit at which x tends to 0 from the right hand side, okay, from the right, is still the same thing as the limit at which x tends to 0 of what? Sine 5x over what? Over 2x, which will still give me what? 5 over 2. Okay, from the right means that what? X is positive. Okay, it's just like now if you have, this is your x, now this side is negative. This is when, let's say this is our 0. Okay, let's say this is our point 0. This side is x less than 0, and this side means what? This side like this is what? X greater than 0. So from the positive side would still be what? Would still be this function. I wish I had a lot of examples for me to for me to explain, but I just think this, I just assume you guys understand what I'm saying from here. So here will still give us 5 over 2. Now what do you notice? You notice that the left limit is still the same thing as what? It's still the same thing as my right limit. Okay, now what is now my f of c? My f of c here is what? Okay, my f of 0 rather. My f of 0 is what? That is when my x is 0 is what? Is mu. But for this thing to be continuous, all these three things must be equal, meaning that what? My mu is just what? 5 over 2. Simple. I'm done. Alright, so let's write this. So our correct answer here is what? 5 over 2. So if you guys understand this video, why don't you just hit the like button? Alright, so let's continue with our question. In this question, we are asked to find the integral of arc sine of 2x dx. Okay, so we need to use our integration by parts. integration by parts. Okay, so here we let our u be equals to arc sine of what? Arc sine of 2x, and we let our dv be equals to dx. Okay, so that means, what's my du? My du is just what? If I differentiate this, so what am I going to have? I need to differentiate my 2x. That will give me 2. Then if I differentiate arc sine of u, I'm going to have this to be square root of 1 minus u squared. So if I replace my u with 2x, I'm just using my chain rule here, nothing more. So I'm going to have this to be 1 minus u squared. So what my u is just 2x, so that means I will have this to be 4x squared. Okay, multiplied by dx. And if I integrate both sides, this will still give me what? My v is just still going to give me x. That means that what? My integral of arc sine of 2x dx would be what? uv, which is x arc sine of 2x minus the integral of v du. So we have v, that's what? 2x over square root of 1 minus 4x squared dx. So that means I need to evaluate this integral. So let me call this integral I1. So let's say we have our I1 to be equals to the integral of 2x over square root of 1 minus 4x squared dx. Now if I let my, since this one is just a radical, I can just let my u, the argument that is under that radical, I can just let my 1 minus 4x squared be equals to u. I know that if I differentiate what's inside here, I'll get something almost similar to what I have at the numerator. Okay, they will be of the same power, so which is still kind of okay. So if I differentiate this, what am I going to have? So that means my du would give me what? So if I differentiate this with respect to x, so that means I'm going to have this to be minus 8x dx. So meaning that what? My dx is just simply du over minus 8x. So that means my I1 can still be written as the integral of 2x over the square root of u. Then what's my dx? That's du over minus 8x, which is what? Minus 1 over 4 integral of du over square root of u, which will give me what? Minus 1 over 4. If you integrate u raised to power minus 1 over 2, you will get this to be 2 square root of u. That's just elementary. So that means I'm going to have this to be minus 1 over 2 square root of u. Okay, so we have this to be 1 minus 1 over 2 square root of u, or you write it as what? Minus 1 over 2 square root of 1 minus 4x squared. Since your u is just 1 minus 4x squared, so you can replace it as that. So that means my original integral, that's arc sine of 2x dx, is simply what? X arc sine of 2x, then minus I1. So what's my I1? My I1 is minus 1 over 2 blah blah blah. So if I substitute it there, that means I'm going to have this to be what? Plus 1 over 2 square root of 1 minus 4x squared, then plus c. Don't forget your arbitrary constant. They can actually deduct your mark if you don't put your arbitrary constant, so don't forget to put it. Now here, answer here is just x arc sine of 2x plus 1 over 2 square root of 1 minus 4x squared plus c. Alright, so let's move on to the next question. In this question, they said if u is equals to ln x squared plus y squared plus arctan of y over x. So we asked to find the second partial derivative of u with respect to x plus the second partial derivative of u with respect to y. Alright, for us to do that, we need to first find the partial derivative of u with respect to x. So if we do that, what are we going to have? So that means we have the du partially with respect to x. So that means we want to differentiate ln x squared plus y squared, then plus partial derivative of arctan of y over x partially with respect to x. And let me just do it one side so that it can make my job easier. So here we want to find the partial derivative of u with respect to y, which is the partial derivative of ln x squared plus y squared with respect to y, then plus the partial derivative of arctan of y over x. Okay, so here don't forget that anytime you want to differentiate a function, the ln of a function, you take the derivative of that function then divided by the function itself. Now if we differentiate this partially with respect to x, so that means we need to differentiate x squared plus y squared partially with respect to x. Okay, that means we have d dx of x squared plus y squared all divided by x squared plus y squared, then plus, that's when we are differentiating this partially with respect to x. Now here we also have arctan of y over x. Now to differentiate this, we need to differentiate this partially with respect to x. Alright, we need to differentiate y over x partially with respect to x, then now multiply it by the derivative of arctan of y over x with respect to y over x. Okay, so we need to differentiate. It's just like chain rule, it works like chain rule. This is an argument here. We need to differentiate our argument here with respect to what? Partially with respect to x, then now multiply it by the normal derivative, just like your normal derivative, all right, of that function with respect to the argument here. We could have replaced our y over x with u. It's still the same thing, but I just decided to write it like this. Okay, now here again we are going to have this to the partial derivative of x squared plus y squared with respect to y over x squared plus y squared, then plus partial derivative of this with respect to y, then multiply by the y over x of what's arctan of y over x. Okay, so here we are going to have this to be, if you differentiate this partially with respect to x, that means we have this to be 2x, while the other one will just be 0 because you'll see the other variable as constant. So now 2x, we have 2x over x squared plus y squared. Then if you differentiate this partially with respect to x, y is just a constant, so that means I'm going to have this to be minus y over x squared, okay, minus y over x squared, then multiplied by, now if you differentiate arctan of y over x with respect to x, y over x, that will give us what? 1 over 1 plus y squared over x squared. Alright, so which will give me what? 2x over x squared plus y squared. Then here if you use minus y over, if you use x squared to multiply this, so that means we are going to have this to be x squared plus y squared. Okay, so that is for the partial derivative of u with respect to x. Now here we are going to have this to be the u dx partial derivative of u with respect to y will be what? Now here we are going to have this to be 2y, okay, divided by x squared plus y squared. Then here if you take the partial derivative of this with respect to y, x is a constant, so that means we have this to be plus 1 over x, then multiply by 1 over 1 plus y squared over x squared. Okay, So if I multiply the numerator here by x, and I also multiply the denominator also by x, so that means this one will just be x squared. So I'm not changing anything. The essence is that I want to have something like this, that's 2y over x squared plus y squared, so that I can equally multiply this, and this will give me what? Plus x over. Now if I use x squared to multiply the argument here, or what's that, the denominator here, I'm going to have this to be x squared plus what? Plus y squared. Okay, so I hope that is clear. Now the next thing for me is now to find the second partial derivative of u with respect to x. So which is still the same thing as you are differentiating the u dx, the partial derivative of u with respect to x, with respect to x. Okay, now what would that give us? That means this will give us the partial derivative of, now what's my du dx? My partial derivative of u with respect to x is just simply 2x minus y over x squared minus plus y squared. Okay, so this is clear enough. Then this will give me, so if I apply my quotient rule, so what am I going to have? So let me write it out boldly. That means I'm going to have the denominator, that's x squared plus y squared, multiplied by the partial derivative of the numerator, that's 2x minus y with respect to x, then minus 2x minus y, then multiplied by the partial derivative of the denominator, that's x squared plus y squared with respect to x, then all divided by x squared plus y squared all square. Okay, again, so what is my die square u die y square? My die square u die y square is just die x of die u die y. Sorry, this should be y because we are taking square. Then this is die y of 2x plus 2y plus x, rather, all divided by x squared plus y squared. Alright, now if I take derivative of this as usual, this should give me x squared plus y squared. Then we have this to be die x, die y this time around, because I'm using my quotient rule, of what? Of 2y plus x minus 2y plus x. Then this will be die y of x squared plus y squared, then all divided by what? X squared plus y squared all square. Now for us to conserve space, if you differentiate this partially with respect to x, that means I'm going to have 2, so that means I'm going to have this to be what? 2x squared plus 2y squared. Okay, and not only that, if I simplify this also, if I differentiate this partially with respect to x, I'm going to have this to be 2x. Alright, so and if I multiply it with this, I'm going to have this to be what? Minus 2x squared. Then here we have this to be what? Plus 2xy. Okay, plus 2xy, then all divided by what? X squared plus y squared all square. And here also, if I differentiate this partially with respect to y, I'm going to have this to be what? 2x squared plus 2y squared minus, now if I differentiate this partially with respect to y, I'm going to have this to be 2y. Okay, 2y multiplied by 2y here, I'm going to have this to be y squared, then minus, so this should be 4y squared minus, this when we differentiate this will give us 2y, so 2y times, that means this will give us 4y squared, then minus 2xy. I think I was missing out something here. This should be 2x, so if you multiply this should be 4x squared. Okay, so this is fine now. 2 times 2 will give us 4x squared, then plus this will give us plus 2xy. All right, so this is fine, which is x squared plus y squared, okay, all square. Now we want to find that square u that x square plus that square u that y square. So what's the answer to this question? The answer to this question is just simply what? Now if I add both of them together, let's call this 1 and let's call this 2. So if I add 1 and 2 together, so what am I going to have? I'm going to have 2x squared plus 2y squared minus 4x squared plus 2xy, then plus 2x squared plus 2y squared, okay, minus 4y squared minus 2xy, all divided by, since they have common denominator, so that means I can write this as x squared plus y squared all square. Now I have 2x squared and I have plus 2x squared, then I have minus 4x squared, that means that will give us 0. 2y squared plus 2y squared minus 2y squared, that will also give us 0. And here I have 2xy minus 2xy, this will also give me 0. So that means the value for this the partial derivative is just what? It's just 0. So if you are familiar with this question and they repeat this question, you don't need to solve it. The answer is just what? 0. So that's why you need to probably study past questions or solve likely questions, like your test questions or your questions from the practice questions given to you in class. All right, so let's just move on to the next question. So the answer to this question is what? The answer to this question is 0. Now question 15, it said obtain the derivative of the function. So here you are given rule x to be what? X multiplied by e raised to the power ln x plus 1 over x squared plus 1. All right, now again you need to observe something, that here you are given e raised to the power ln x plus 1 over x. This is just itself, it's just x plus 1 over x. So that means the rule x can be written as x multiplied by x plus 1 over x divided by x squared plus 1. And if I simplify this, I will have x squared plus 1 over x squared plus 1. And if I differentiate this, I will have this to be, if I differentiate both sides with respect to x, that means my rho prime of x is just what? It's just 0, because if you differentiate 1 with respect to x, that means I will have what? 0. Okay, it's just a constant function, and that means the slope is just what? 0. So the answer to this one is 0. So you have to just look out for all these kind of questions that will not waste your time and it will still attract you more marks. Okay, so let's move on to the next question. In this question, they said that we should use first principle to differentiate e raised to power 3x. Now here we are given y to be equals to e raised to power 3x. We are asked to evaluate the y delta y over delta x. Now if you increase y, that means I'm going to have y plus delta y to be equals to e raised to power 3 into x plus what? Delta x. And this, you can write this as 3x multiplied by e raised to power 3 delta x. Okay, so that means my delta y is simply e raised to power 3x multiplied by e raised to power 3 delta x minus y, which is e raised to power 3x. Or you write this as e raised to power 3x multiplied by e raised to power 3 delta x minus 1. Okay, so that means we have delta y to be equals to e raised to power 3x multiplied by e raised to power 3 delta x minus 1. Okay, and if you divide both sides by delta x, that means my delta y over delta x is what? is e raised to power 3x open bracket e raised to power 3 delta x minus 1 over delta x. So this is just my answer. So the answer to this question is what? E raised to the power of, so that means my delta y over delta x, delta y over delta x is simply e raised to the power 3x open bracket e raised to power 3 delta x minus 1 over delta x. Okay, so that's just your final answer. Now question 17, we are asked to find, it said given that our y is, so let me try to rub this off before we solve question 17. So question 17 said if y is 2 plus x over x squared plus 2x plus 7. So we are asked to find the y dx at point x equals 0, at x equals to 0. Now if you want to differentiate this, that means we apply our quotient rule, which means that we have x squared plus 2x plus 7 multiplied by the derivative of 2 plus x with respect to x minus 2 plus x multiplied by the derivative of x squared plus 2x plus 7 divided by what I have at my denominator all square, that's x squared plus 2x plus 7 all square. So that means I'm going to have this to be x squared plus 2x plus 7. If you differentiate this, this will give us 1, then minus 2 plus x, then if you differentiate this, this will give us 2x plus what? Plus 2, then divided by x squared plus 2x plus 7 all square. So this might be dy dx. So if I substitute there 0, that means the y dx at x equals 0 would give me 7, because this will give us 0, 0 minus 2 open brackets. Of course, if you put 0 here, this will give us 0, that means 2 open bracket 2, then over 7 all square, which is what? 7 minus 4 will give us 3 over 49. So the correct answer to this question is 3 over 49. And the last question for today, oh, not the last question, we still have 2 more questions left. So question 18, there we are asked to find the derivative of square root of 1 plus ln 3x squared minus 4. Alright, so here we are given our f of x to be equals to the square root of 1 plus ln 3x squared minus 4. So here, if I let my u be equals to 1 plus ln 3x squared minus 4, that means that what my f of x will just be what? Square root of u. Now if I differentiate my u with respect to x, that means I'm going to have this to be 6x, because if you differentiate 1, that will give you 0, and if you differentiate ln 3x squared minus 4, this will give us 6x over 3x squared minus 4. And not only that, if I differentiate my f of x with respect to u, I'm going to have this to be 1 over 2 square root of u. So meaning that my df of x dx is what? D f of x du, or yes, du multiplied by du dx, which is simply what? Which is simply 6x over 3x squared minus 4, then multiplied by 1 over 2 square root of u, which is which will give us our u, which is 1 plus ln 3x squared minus 4. Okay, and here 2 here will cancel this, then this will cancel this to be 3, so that means I'm going to have this to be 3x over 3x squared minus 4 multiplied by the square root of 1 plus ln 3x squared minus 4. Finish. So here we have this to be 3x over the square root of, okay, so before the square root we need to write our, so here we have this to be 3x squared minus 4 multiplied by the square root of 1 plus ln 3x squared minus 4. Alright, so let's move on to the last question for today. In this question, question 19, they said using the substitution x equals to tan theta, evaluate the integral of, so we are asked to evaluate the integral from 0 to 1 of 1 minus x squared over 1 plus x squared all squared dx. Okay, so want to use the substitution x equals to tan theta. Now here, if we let our x to be equals to tan theta, that means that our theta is simply arctan of x. Okay, now that means that if you differentiate x, okay, that means we are going to have this to be what, sec square theta d theta. Okay, now don't forget that we need to transform the limit. Now if we do that, so what are we going to have? We are changing the limit from theta, from x to what, to theta, right? So that means here we're also going to change this one from 0 to, so if our x is 0 from here, that means our theta is going to be a tan of 0, which is what, 0. And if our x is 1, what to be our theta? Our theta is just what, pi over 4. That is, arctan of 1 is pi over 4. That's clear enough. Now if we do some manipulation, that means the integral from 0 to 1 of 1 minus x squared over 1 plus x squared all square dx will simply transform to the integral from 0 to pi over 4 of 1 minus, what's our x? Our x is tan theta, so that means this will be what's tan square theta all divided by, now here we have this to be what, 1 plus, what's our x? That's tan square theta all square, then multiply by sec. Now what's our dx? Our dx is what, sec square theta d theta. Okay, so that means this would reduces to pi over 4 of 1 minus tan square theta all divided by, now what is 1 plus tan square theta? 1 plus tan square theta is just still the same thing as what, it's still the same thing as what, sec square theta. Okay, so this is still the same thing as sec square theta. Okay, now just from your idea of sin square theta plus cos square theta to be equals to 1, so what I'm saying in essence is that if you have your sin square theta plus cos square theta to be equals to 1, so if you divide both sides by cos square theta, so you are going to have tan square theta plus 1 to be equals to sec square theta. Then you have this to be what, all square, then you have this to be multiplied by sec square theta d theta. So that means I'm going to have this to be the integral from 0 to pi over 4 of, here I'm going to have this to be integral from 0 to pi over 4 of 1 minus tan square theta over, here I'm going to have this to be sec square theta sec square theta, because sec theta will cancel one of the sec square theta will cancel one of the sec square theta here, so I'll just have this to be just one sec square theta d theta. Okay, and now if I try to simplify this also, I have 1 minus tan square theta over sec square theta. So this will give me what? 1 over sec square theta. Alright, then minus tan square theta over sec square theta. Alright, so that means that this would give me here 1 over sec is cos square theta. Alright, sine square theta. That is, if you simplify this, you are going to have this to be sine square theta. And now, what is cos square theta minus sine square theta? Cos square theta minus cos square theta minus sine square theta is just what? Cos 2 theta from your elementary trigonometry. Alright, so we have this to be the integral from 0 to pi over 4 of what? Cos 2 theta d theta. And if you integrate this, you are going to have this to be 1 over 2 sine 2 theta. Alright, then you are taking the lower bound to be 0 and the upper bound to be pi over 4. And if you substitute that, you are going to have this to be sine 90 is 1. So that means we have this to be 1 over 2. And sine 0 is what? 0. 1 over 2 multiplied by 0 is still what? Sorry, it should be 1. Then that means this is what? 1 over 2. Final answer. So the correct answer to this question is what? 1 over 2. Over 2. All right, so let's move on to the last question for this tutorial series. So in this question, we want to use the integration by parts to evaluate this integral. So here we are given the integral from 2 to 4 of ln x dx. Okay, so here we let our u be equals to ln x, and we let our dv be equals to dx. So that means our du is what? Dx over x, and our v is what? It's just x. So meaning that the integral from 2 to 4 of ln x dx would be what? X ln x. So taking the lower limit to be 2 and the upper limit to be 4, minus the integral from 2 to 4, that's du dx, will give us just dx. Okay, so that means here we have this to be 4 ln 4 minus 2 ln 2, then minus, now if you integrate dx, that means you are going to have just ordinary x, and if you put the lower limit to be 4 minus the upper minus the lower limit, upper limit minus lower limit would give us this result. So and here we are going to have this to be 4 ln 2 minus 2 ln 2 minus 2. Okay, so here we have this to be, this is 4 ln 4, then here this is 2 raised to the power of 2, which is still like 8 ln 2 minus 2 ln 2 minus 2, and this will give us 6 ln 2 minus 2. Okay, so this is our correct answer, 6 ln 2 minus 2. Now if you use calculator to evaluate this, now let's try to use calculator to evaluate this. Now here we have the integral from integral of ln x, all right, taking the lower limit to be 2 and the upper limit to be 4. Now you see that this is giving us a decimal number. If you write the decimal number out, they will not give you your full mark. They want you to write the close approximation of this integral, the close form of it, which is 6 ln 2 minus 2, which is like 2.15 or 2.16. So yeah, 6 ln 2 minus 2. you see that to give you something like that. But if you go and write this out like this, they won't give you the answer. And there's no how calculator, some calculator will give you the closed form of it. Okay, this particular kind of calculator will never give you the closed form of this answer. So if you go and write out your answer, they will not give you your answer, they will not give you your mark. So you must try to evaluate that integral using the normal integration technique. Well, we've come to the end of today's tutorial questions. If you have any question, any comment, any suggestion you want us to know, you can put them in the comment section box below. And also don't forget to click on the like button so that more people can get to know about this. And together let us defeat this academic failure. Thank you.